When you know your basic functions, which still yesterday some people didn't know, like I said, what does the absolute value look like? You need to know that's V shape. What does the square root look like? It's half of a parabola. What does x cubed look like? It looks like an S shape. Like you need to know those functions that we wrote out from 3-4. And then if you know the rules for transformations, you can graph these pretty quickly without having to pick a million points. If you don't learn these, it's going to take you a long time to make these graphs, which is not the idea of these problems. So, I don't know if I wrote this on here or not. Again, I think I wrote this extra name again. Yeah, graphic techniques, transformation. There are rules for how you know if a graph has moved up, down, left, or right. And so we're going to kind of break them up in sections and look at a few examples. But you're definitely graphing on your work today. I think there's 6 graphs that you have to graph. You okay over here, Bryce? All right, so if your graph is shifted up or down, then it is a number added or subtracted outside the function. And so I'm going to write this in terms of just f of x, and then I'm going to give you a real function out next to it so you can kind of see what it looks like. But if your graph is shifted up so many units, we say c units, then you just add a number to the outside. So like a quadratic, if I said x squared plus 4, notice the plus 4 is not inside that quadratic. It's outside of it. I know just by looking at that that it moves up 4 units. So I take that normal little x squared and I just move it up. No xy chart needed if you know what it looks like. And if you subtract a number outside of your function, then you move it down. And so I'm going to use a different function, like a square root function, like the square root of x minus 3. Again, notice the minus 3 is not in that radical, it's outside of it. That means that it moves down 3 units. In pre-calculus, I always make the kids like do problems where they have to write, like, tell me what the transformation is. On your unit test, they just want you to be able to graph them. They don't make you like say what's happening. Knowing what's happening is very helpful, but worst case scenario, you can make an XY chart and you can get that graph even if you have no clue what's happening. So hopefully that people will get that. So vertical shift is outside. If you have a horizontal shift, notice the difference here. I'll give you a second to write this, and then we'll write it out. Horizontal means that you're shifting your graph to the right or to the left. Notice the difference in this. Now you're adding or subtracting the number inside the function. Also notice the signs are kind of opposite of what you think. If you're moving to the right, you probably would think you're adding a number, but you're not. You're actually subtracting. So that would look like if I had like the absolute value of x minus 1. Notice the minus 1 is inside the absolute value bars. That means it's moving to the right one. So I would put right 1 unit. Or if I'm shifting it to the left, if it goes back, you actually add a number inside. So what could I do there? I could do like x plus 2 to the 3rd power. That means I'm taking the x cubed function, but I'm shifting it back 2 units. So that would be left 2 units. Any vague memories of this from previous years? Pre-cal, we hit it really hard in pre-cal, but in algebra 2, every graph that you learned in algebra 2, you went over these values again. I think you usually called these numbers h and k, and the number in front is a. But every graph, the same rules apply. If you add a number outside, it moves it up. If you add a number inside, it moves it left. And so, hopefully, hit those over and over again that you kind of remember them. Let's see if I have some more. Everybody done writing this? All right, let's look at a couple graphs before we add some more rules here. Most of your homework today graph is the original function, like in this case would be x squared, and then this would be the transformation. So that means you have like 2 graphs on every graph. So just make a little graph here. And I'll give you graph paper for your homework. I picked 6 problems on purpose because my graph paper has 6 graphs on it. So that way I didn't have to give you 2 pieces of graph paper. I could have gave you the double-sided 6 on each side and made you do 12 graphs, but I decided I didn't want to make you do 12 graphs. I'll probably get a lot of complaining with just 6 graphs. But the idea is that you know what x squared looks like and that you don't have to make an xy chart. If you don't know what these graphs look like that we wrote out the other day, then you have to pick points every time. And x squared is a what shape graph? Parabola, a U shape. So if I was going to graph that, I know that it starts at 0, 0, and then on each side of that, when I plug in 1 and -1, it goes up to 1. When I plug in 2, it goes up to 4, because 2 squared is 4. And you should know that that's what I call that parent graph looks like. I would label that. Okay. Oh, we're not there. I'm not there yet. I'm graphing this first. So on your homework today, you have to graph the original one first, and then we're going to come back and we're going to graph the transformation. What does that -3 mean I'm doing to my graph? Yeah, I'm shifting it down 3. I'm not changing the size of it all. I'm just moving it down 3. So theoretically, it's like picking this graph up and just moving it down 3. Let's see if I can do that. I don't think I can. Oh, look. 1, 2, 3. I haven't changed the shape at all. You can't do that on your paper, so we actually have to make some points again. But it's where the same shape applies. So when I move it down 3, you could pick points, but the idea is that you know the shape is the same. When you go over 1, you're going to go up 1. When you go back 1, you're going to go up 1. When you go over 2, how many are you going to go up? 1, 2, 3, 4. Go over 2, 1, 2, 3, 4. Sometimes you realize how terrible you made your graph when you're trying to line that up. And so the shape hasn't changed. It's just shifted down 3. And that would be g of x. If you didn't know that, you just make an xy chart and you just pick a bunch of points until you get that shape. I like to try to think about what's happening before I graph it, but again, you're not required to. You can just make xy chart. But for me, when I look at a problem like that, I like to think about what transformations are happening before I graph it. As you're making your graph, go ahead and make that parent graph again. Go ahead and make x squared, just so you can think about what's happening to your graph compared to this graph. What does this +1 on the outside mean my graph is doing? It means it's going up 1. And what does that +2 inside the function mean that it's doing? It's going left 2. It's the opposite of what you think. It's actually going back 2. So it's going up 1 and left 2. That's kind of like the vertex. So when I graph this problem, I'm not going to make an xy chart. I'm just going to say I'm going up 1 and back 2, which means that point has moved over there. Back 2, up 1. And you can pick points, but the shape should be the same, which means when you go to the left and right 1, you should be going up 1. And if you go over 2, it should go up 4 and be that same shape. I kind of missed there a little bit. I do expect that you label some points on here. Like, you don't have to like put your ordered pair, but I expect to see points that you're not just like making a dot and winging it from there. I will be kind of picky on that when I'm grading these. transformations. Not so bad, right? Left and right. What else can we do? We can reflect it, and we can stretch and shrink it. Stretch and shrink's where it gets a little crazy. But let's see if we can finish this first. If you put a negative in your function somewhere, that's going to be a reflection. We're reflecting the x-axis, we're reflecting the y-axis. If you forget which is which, you can always pick a point and see what's happening. But if you put a negative out in front of your function, so negative f of x, then that means that it is going to flip over the x-axis. And I always think about, that means your y values are changing. You pick the same x values, but now your y values are all negative. So I just gave you an example here. If the parent graph is y equals the absolute value of x, then its reflection in the x-axis would be if I put a negative out in front of the absolute value, then it now is reflected over the x-axis, because now I'm going to get all negative y values. Again, this is where knowing the shapes are important. What shape is the absolute value graph? A V shape. So if I graph absolute value, if you plug in 0, you get 0. If you plug in 1, you get 1. If you plug in 2, you get 2. Plug in negative 1 and negative 2, you get the same thing, which means it's not a parabola shape, it's straight line, the V-shaped graph. That's the original graph, or I call it the parent graph. And these are ones that I always say, if you forget, just pick a point. But on this one, if you plug in 0, you're still going to get 0. But what's happening is now all my y values are negative. Because when I plug in 1, I still get 1, but now I have a negative in front of that. So now I get negative 1 and negative 2. And when I plug in a negative inside there, it's still the absolute value is positive, but that negative in front flips it over. So that means, again, if you notice it's a reflection, you should just be able to graph it without really picking any points. And it would look like that. Yours is all in the same color. It just looks like you made a big X on your graph. So if a reflection in the x-axis is when you put the negative out front, a reflection in the y-axis is going to be if we put the negative inside the function. And again, I'll just show you a graph here of this. And again, notice my problem here. I actually threw in a +2 at the end also. But I have the square root of x, and then I put a negative inside that square root. So if it reflects on the y-axis, that means the negative is inside the function, not outside the function. Some functions, if you plug a negative in, they don't change. Like this. If I put a negative inside here, it doesn't change because they just flip places, but it's already reflected. Like, it's symmetric about the y-axis, so it doesn't change. What does this +2 mean is happening in my graph? Outside, so that means it's moving up 2. So both of these are moving up 2, but one of them just reflected. So what does a square root graph look like normally? Half of a parabola on its side. You could pick some points here. Oh, I need more points in this, that's alright. I always say pick perfect squares in here. So like if I was going to graph this, if you're not sure what it looks like, I would pick 0. Because 0 plus 2 is just 2. That's why it moves up 2. Normally it starts at 0, 0. And normally when I plug in 1, I get 1 because the square root of 1 is 1. But on this one, if I plug in 1, I get 1 plus 2, which is 3, because it moved up 2. And you can kind of just go from there, but I'm going to pick one more point. If I pick, what's the next perfect square? 4, we get 2 plus 2, which is 4. And this is where you gotta know the shape. I know it's half of a parabola on its side, so picking 1 or 2 or 3 points is enough for me because I know what shape it's supposed to be. If you don't know what shape it's going to be, there's a good chance you're going to make your graph wrong. So those graphs that we wrote out in 3-4, I cannot stress enough that you need to be comfortable. When you see it, you know how to graph it. But think about on this side. You can't take the square root of a negative number, and so your x values change. You have to pick negative x values, except for 0. 0 is still going to be 2. But you have to pick like -1 because that has to become a positive. So then that would still give you 3. But you have to pick -4 to still get the same value. So when the negative's inside, your x values change. That's how I think about what's happening here. But it's the same thing. It's just flipped over. So I don't even have to really make marks here. 4, 4. It's just going to look like that. Roughly speaking. Questions about those reflections? Usually people do okay with the sliding left, right, up, or down. Reflecting is not so bad, even though I pick points. But then the other type of transformation is stretching and shrinking, or this book calls it stretching and condensing instead of shrinking. And that's where it changes the shape. It stretches that parabola out and makes it really skinny, or it condenses it down and makes it really wide. And there's some shortcuts with this, but sometimes on these you kind of just want to make an XY chart. So let's write these rules out, and then we'll go from there. Again, you don't really have to write these 2 things. I'm okay. You could just start here if you want. But I just kind of explained what I just talked about. What we just did, shifts and reflections, we call those rigid transformations because they don't change the shape. But if your transformation changes the shape or causes distortion in your graph, we call those non-rigid transformations. But you don't really write that down. You can start right here. The other good thing about this class, again, as opposed to pre-calculus, I made you memorize these and say that's a vertical stretch or that's a horizontal shrink. And these you just have to know how to graph it. And again, XY charts always work. Notice that both of these, a vertical stretch and a vertical compression, is when the numbers multiplied out front. What makes the difference between a stretch and a compression is what C is, whether C is bigger than 1 or whether C is a fraction between 0 and 1. So an example of a stretch would be like if I said g of x equals 3x squared. The 3's outside the function, and that's bigger than 1, so we would say that that's stretched 3 times. So it's 3 times as skinny. Instead of going over 1 up 1, you'd go over 1 up 3. And a compression, same idea, it's just that this is a fraction. So what if I said 1/3 x squared? That means that's going to be like 1/3 the size squished down, which means you'd have to go over 3 in order to go up 1. And we'll look at one of these, we'll graph one of these in a minute. So the big thing that I like to point out is vertical is if the number is on the outside of the function. Horizontal is if the number is inside the function. Kind of just like vertical and horizontal shifts. So if I said g of x equals the square root of 2x, and notice that 2 is underneath the square root, that means instead of stretching it, oh, that's totally wrong. Look at my rule here. If it's a stretch, that should be a fraction, so we should say like 1/2 x, sorry. So that means it would stretch it long ways, horizontally. And a horizontal compression would be if it's bigger than 1. Looking at the graph, you could write a horizontal compression as a vertical stretch. Like it just depends on what it is. They can be very much switched around. But I just want you to be able to graph it. If they give you an equation, which is what you're doing on your homework today, I want you to be able to graph it. And again, XY charts are a great thing to lean on if you struggle with this, because it's kind of a lot of work. So I think I have 2 more and then I'm done for today. 2 more graphs. That's it. Only 2 more. This was like 23 minutes. Only 2 graphs left. That's a lot. Okay.
So we're graphing these 2 then?
Yes. 2 examples that we're going to graph with stretches or shrinks. Compressions. No, that's fine. And you're going to do it with your homework. Again, it says compare the graphs of f of x equals absolute value to this one, and again, we're going to graph both of them. When you see a number multiplied, I just want you to recognize that that is going to change the shape of your graph. Whether or not you know what that is, whether or not you know that's a vertical stretch by a factor of 2, not really that important in this class, because they just want you to be able to graph it. But just recognize that it's not going to be the same shape. Let's go ahead and graph the original one, like we did before. And so I'm going to graph that one in black again, just kind of to mimic this. But absolute value, you have to know that that's a V-shaped graph. That's one thing, I guess, that would really slow people down on the unit test. If you don't know your graphs and you have to make an XY chart every time, that's going to take you a lot longer to graph than it's going to take me to graph. If we put a 2 in front of that, that just means it's going to stretch it by a factor of 2. If you're not sure what that does to your graph, all you got to do is make an XY chart. You already know it's going to be a V shape. You just need to pick a couple points and just look what happens. If we plug 0 in there, we're still going to get 0 because 2 times 0 is still 0. But when we plug any other number in there, it's going to double it. It's going to stretch it by a factor of 2. So if we plug 1 in there, we get 2. If we plug 2 in there, we get 4. And so it's still going to be that same shape, but it's going to look a little bit thinner because it's stretching it out. Same thing if I plug the negative numbers in, it's going to stretch it up there. And so it's still going to look like a V shape. Totally missed that point. But it's just going to be thin. If you have a stretch or a shrink plus like a shift, just pick a couple points and see what's happening there so you can get the idea of where it starts. Let's just look at what happens if we go the other route like this. My last one, I do believe. It's a terrible graph I made over there. I missed both points on it. That says negative 1/3 x. So the 1/3 means it's compressed. What does the negative out there mean? It's flipped down. So again, you don't have to write that out on these problems, but it's nice to think about that. It should be kind of squished down, and it should be flipped over. So if I don't get that, then I know that I've done something wrong. Again, I'm going to make my paragraph here just because your book makes you do that. Again, XY charts are not, the worst thing in the world here. But for me, if I see a fraction, I don't want to graph fraction, so I'm going to try to pick numbers that make that fraction go away. So if I pick 0, I still get 0. What would be a good point to pick here so I don't have to graph correction? 3, because if I pick 3, then 3 times negative 1/3 is going to give me negative 1. So think about what that means. If there's a 1/3 in front, normally if I go over 1, I go up 1, but it's compressed it by a factor of 3, so now you have to go over 3 just to go up that same 1, but we're not going up because the negative means we're going down. Do you have to think about that? No. You could just make an XY chart and graph it and never have to think about it at all. I didn't make my graph big enough, but the next one I'd graph would be 6, and if I put 6 in there, I'd get negative 2. But you notice how that's going to be a lot wider looking graph? Still a V shape though. I tried to pick problems on your homework today to give you a variety of ones to graph. If you forget what they look like, go back to 3, 4 notes. We drew out all 8 of those graphs. If you forget what x cubed looks like, if you forget what the cube root of x looks like, those are things that this would be good review for, because you are expected to be able to graph those on your unit test by hand. Okay? I have graph paper for you. These are my directions here on these. Okay, so I think this is 6 problems, 39, 42, 45, 48, 51, 54. And so there are 6 problems, or 6 graphs on my graph paper, and there's even room next to it. So you don't even need your own sheet of paper. You can just graph it and put your work next to it. How amazing is that graph paper? The directions in the book say all this stuff. Like start with the graph of the basic function and show all stages. You don't have to do that. But I do want you to graph the original function. So if it's x squared, you graph just x squared, and then graph the transformation. And I do want you to give domain and range on each one of these problems. No, just the domain of the new graph. I mean, you can give whatever you want, but I just want the domain of the new graph. And you actually have a good amount of time to start on this, so if you have questions, you can ask me. Make sure you know what shape you're graphing, and also make sure you make an XY chart. If you get stuck, just make an XY chart. A big part of your unit test is graphing, so don't think that you can just skip this and be okay. Just give everyone graph paper. I guess if